Today we're going to look at dilations, which is a change in the coordinate plane. Our learning target is I can identify and graph a dilation, and our essential question is not the one that's printed, but is how is a dilation not a rigid motion? Don't forget to fill out your name, the class, and the date. Sorry about that. Okay. A dilation is a transformation, which just means a change or move, whose image is the same shape. So if it's a triangle, it'll stay a triangle, but a different size. We can see that down here. We have triangle ABC, and we also have a similar triangle ABC, but it's larger. Since the pre-image and image are different, a dilation is not an isometry or a rigid motion. We can have an enlargement or a reduction. So an enlargement is when our image, when it grows, right? So we'll say grows. And a scale factor we represent with the variable k. And when our scale factor is greater than 1, the image will grow. And when our scale factor is between 0 and 1, we say it shrinks. So it can be a decimal or a fraction. Okay. And so our scale factor is represented by the variable k. Example 1, identify if the dilation is growing or shrinking. Well, the first thing we have to do is we have to find our pre-image, and that's where we start. That's where just the letters are. So this four-sided figure that's small is our pre-image. And our image, which has the prime or x moved once, is the large image. So we're going small to large. So this is a growth. Oops. So we can write grow. The image on the right, we can see triangle ABC is the large triangle, and then the move or the change is too small, so we can say this shrinks. So the trick to identifying whether it's growing or shrinking is to get your pre-image correct. All right, let's graph. So example 2, complete the transformation. So we're gonna do a dilation of about 2. So our scale factor is 2. All this means is to multiply x and y by 2. So the rule would be if I take any ordered pair and I want to dilate that, but I want to dilate by a factor of 2, I'm just going to take 2 times x and then 2 times y. And that's it. So they give us our ordered pairs. So G is -1, -1. H is -2, -2, or -2, +2. I, 0, 1. And J, 2, -2. Okay, I can also list them here, H, I, G, and J. H is -2, 2, I, 0, 1, G, -1, -1, and J, 2, -2. Okay. And I'm going to change them all. What I'm going to do is I'm going to take 2 times x. So if I take 2 times -2, I get my h prime, or h moved once. So 2 times -2 is -4. And 2 times +2 is +4. So h prime is going to be -4, 4. 2, 3, 4. 1, 2, 3, 4. So h moved once, or h prime, is 4, -4, 4. Let's do that again for I prime. So I'm going to take 2 times 0. Well, anything times 0 is just 0. And 2 times 1, which is 2. So on my coordinate plane, 0, 2 is going to be I prime. And I can see that the points are starting to move away from the origin. So they're starting to grow away from the origin. G prime, so 2 times -1 is -2. And 2 times -1 is -2. So G prime, -2, -2. And J prime, 2 times 2 is 4. And 2 times -2 is -4. So on my coordinate plane, I'm going to count 1, 2, 3, 4 to the right, and 1, 2, 3, 4 down will be my J prime. All right, now I want to connect my enlargement. And I also want to connect my pre-image. And we can see that the image did grow. Great. So our dilation is just a number or a scale factor that we're going to multiply both x and y by. Let's do another one. Okay, we've got dilation of 0.5 about the origin. So my scale factor, or what I'm going to multiply by, is just 0.5. Or, right, divide by 2. So I'm going to multiply by 0.5 or divide by 2. If we look at that as a rule, I'm going to take my x value and multiply it by 0.5. And I'm going to take my y value and multiply it by 0.5. Let's see, we've got w, x, y, and z. Let me list my points. Feel free to stop the video at any time. So w prime, x prime, y prime, and z prime is what we're trying to find. And we find them by multiplying 0.5, or half, times -2. Well, I like to think this one in terms of half. So if I take half of -2, I have -1. And 0.5, or half of -1, is -0.5. That might be interesting to graph. Let's see, so I'm going to graph this w prime. So if I graph -1, -0.5, I'm going to the left one and I'm going down a half. That is my w prime. Okay. And let's keep going. So let's see, I'm taking half of -3. That'd be -3/2, or -1.5. And half of 2 is just 1. Let's graph that because that's weird. So -1.51. So I'm going to go to the left 1.5, and then I'm going to go up 1. That's going to be x prime. Okay, so y, I'm going to take 0.5 times -1, so that's going to be -0.5. And 0.5 times 2, or half of 2, is just 1. So y prime is going to be, from the origin, I'm going a half of a unit, not a full line, just a half, and up 1. And z prime, so I'm taking 0.5 times 3, so half of 3 is 1.5, and half of 0 is just 0. So I'm now going to the right 1.5, but I am not going up or down any. All right, and if I connect those together, which will look better on your papers, we'll see we have our image. Now, I waited to graph my pre-image so that you could see how the graphing of half units would be. But we need to go ahead and put in our W, X, Y, and Z. So -2, 1 is our, oops, -2, -1, excuse me. There we go. So -2, -1 is our W. -3, 2, 1, 2, 3, 1, 2 is our X. We see it's farther away from the origin, it's growing away from the origin. -1, 2 is our Y, and our Z is 3, 0. We connect our pre-image, we see it is larger than our image, which confirms that we did have a shrink. Okay, great. One more. So don't let those negatives, don't let the 0.5s, the fractions, slow you down. Okay, number 3, we've got a dilation of now -2. So our K factor is -2, but that's okay. We just are going to take every point and multiply it, our x's by -2 and our y's by -2. Oops, -2y. So we'll take our F, our G, our H, I, and we'll move them. Okay, so I am going to first plot my F, G, H, and I, make my pre-image, another 4 shaped figure, and I'm going to multiply my x value of -2 times -2, so I get +4. My y value is 1 times that by -2 is -2, so my f prime, or f moved once, is going to be 4, -2. And we see since we had a sign change on both our x and our y, we have a little rotation too. So here we have -2 times -2 gives us +4, and +2 times -2 gives us -4. So G, 1, 2, 3, 4. T prime H, -1 times -2 gives us 2, and 2 times -2 gives us -4. 2, -4 gives us H prime. I'm going to connect these as I go. And I, 2 times -2 gives us -4 and +4. So 1, 2, 3, 4. 1, 2, 3. There's our I prime. So this one's really different. Not only did we grow, but we also had a little rotation of 180 degrees. Interesting. Okay. So here's our U try. So these are just like example 1, where I just need to say whether they grow or shrink. And then we graph. These are just like example 2. I think there's just 3 that you need to try on your own, and you're going to do great. We'll see you next